When dealing with an SN1 SN2 E1 E2 reaction, I like to go through our checklist. Is the base strong or weak? What's the classification of the substrate? And is the solvent protic or aprotic? So let's take a look at the base. This oxygen right here has a negative charge, but also know that it's an oxygen, so it's highly electronegative and it wants to hold on to these electrons. So it's a weak base. But because of that negative charge right here, I also know that it's a strong nucleophile. But let's move on to the substrate. I notice there's an electrophilic carbon right here because of the bromine. And this electrophilic carbon is a secondary carbon, so it's a secondary. And the solvent, there's an OH group right here, so it's a protic solvent. Now that we know all the information, let's go through our options. We have SN1, SN2, E1, and E2. Right off the bat, we can eliminate E2 because an E2 reaction requires a strong base and we have a weak base. Now for E1, this prefers a tertiary carbon, and SN1 also prefers a tertiary carbon, and we have a secondary carbon. And these still can react with our secondary carbon, but only under neutral conditions. And since we have this negative charge right here, the conditions are not neutral, so we know it's not SN1 or E1. So that leaves us with just SN2. So how do we draw out an SN2 reaction? Let's first draw out the mechanism. This oxygen right here goes and performs this backside attack on this electrophilic carbon and breaks this bond, leaving the remaining oxygens or electrons to stay with the bromine. So when we draw out the substrate, it would be a dash. Because of that backside attack, it would be inverse of the wedge. So we would then draw our oxygen with the acetate attached. And then we'll have our bromine with our negative charge. And that's how you solve this reaction.